Bismillahirrahmanirrahim. My name is Hassan, and in this video we will discuss the implementation of a half adder subtractor, full adder and full subtractor, and we will implement their circuit on Proteus. The circuit of half adder. In half adder there is two inputs A and B and one sum and carry out. There is no carry in half adder. The difference between half adder and full adder is there is a carry in here and a with two inputs. Similarly, in half subtractor, now these are the basic circuits of the half adder and half subtractor. This is the half adder circuit, and this is for half subtractor, and these are the implementation through the NAND gate. Now we go to the Proteus here. Here we draw the circuit using similar circuit on Proteus. Now we verify their truth table by simulating this. Here when it is 0 0, it shows sum is equal to 0 and carry out is also 0. Here is the input A and B input, and this light shows the sum, and this shows the carry out. Both are the 0 0. This is the gate implementation. We check this also. When both are the 0 0, the sum and carry out both are 0 0. When A is equal to 0 and B is equal to 1, here A is equal to 0, B is equal to 1, the sum is equal to 1 and carry out is equal to 0. The sum is equal to 1 and carry out is equal to 0. Now when the A is equal to 1 and B is equal to 0, A is equal to 1, B is equal to 0. Similarly here A is equal to 1, B is equal to 0. Here again the sum is equal to 1 and carry out is equal to 0. The both circuits work similar. Both circuits are similar, and when the both AB are 0 0, then the carry out is equal to 1 and sum is equal to 0. You can see that the truth table is verified by these both circuits. Now we verify the half subtractor here. When the input is equal to 0 0, here is a 0 0 and this also 0 0. We can see that the difference is also 0. Here is a difference, and here is a borrow. Difference is also 0 and borrow is also 0. Both are 0 0. When A is equal to 0 and B is equal to 1, the both difference and borrow are the 1 1, as we can see from the verify from the circuit, both of circuit. And when A is equal to 1 and B is equal to 0, A is equal to 1 and B is equal to 0, difference is equal to 1 and borrow is equal to 0. And when both are 1 1, different and borrow both are 0 0. So this circuit is also verified. Half subtractor circuit is also verified by the truth table. Now we go to the next full adder here. Now here is a full adder, full subtractor, and using NAND gate and with shorter form. And here is a truth table of the full subtractor. Now we go to the Proteus. Here we draw the full subtractor in the both forms. We will verify this truth table by through the implementation and simulation of this. We run the simulation here. When we can see that when A, B and borrow in are the 0 0, then the difference and borrow out is also 0. Here is a borrow in, and here is a borrow out. When all are the 0 0 0 0 here, and the difference and borrow out is 0. Similarly here, when all the 0 0 and here is borrow out and difference is 0. When it borrow in is equal to 1, here is borrow is equal to 1 and this one, then the difference of borrow out both are 1 1. Similarly, when the b is equal to 1, here b is equal to 1, here also b is equal to 1, then again borrow out and d is equal to difference is equal to 1 1. Then we go to the next stage. Here b and borrow in is equal to 1 1, b and borrow in is equal to 1 1. Here we can see that the difference is equal to 0 and borrow out is equal to 1. Difference is equal to 0 and borrow out is equal to 1. Similarly here, now a is equal to 1 and all other b and borrow out is equal to 0 0, a is equal to 1, b and borrow out is equal to 0 0. We can see that the difference is equal to 1 and borrow out is equal to 0. Difference is equal to 1 and borrow out is equal to 0. Similarly here, now we go to the next. A and borrow in is equal to 1 1, a and borrow in is equal to 1 1, and then both are the difference and borrow out are 0. Similarly here, now we go to the next. When a and b is equal to 1 1 and borrow in is equal to 0, a and b is equal to 1 1 and borrow in is equal to 0, then again difference is also 0 and borrow out is also 0. Similarly in circuits, when the a b and borrow in all are 1 1, here we do all 1 1, it shows the difference is equal to 1 and borrow out is also 1. Similarly in this circuit, that's the full adder, full subtractor and full subtractor using NAND gate. So there the truth table is verified by the implementation of circuit in Proteus. Now we go to the full adder. Here is a logic circuit of the full adder, and here is a logic circuit of full adder using NAND gate, and here is the truth table. We will verify this now. Now we go to the here is a full adder logic circuit, and here is a using NAND gate, and this is the truth table of full adder. Similarly, we verify this. Here we can read the truth table. When a b and carry in is equal to 0, the sum is equal to 0 and C out is equal to 0. We run the simulation here. When all is equal, a b and carry in is equal to 0, the sum and C out is equal to 0. Similarly here, when the carry in is equal to 0, carry out is equal to 0, and when AB inputs are 0 0, that sum is also 0. Now we go to the next. When A, B are the 0 and carry in is equal to 1, here is a 1, it shows the sum is equal to 1 and carry out is equal to 0. Sum is equal to 1 and carry out is equal to 0 here. Similarly in this circuit, both circuits show this similar behavior. Now B input is equal to 1 and carry in and A is equal to 0. B input is equal to 1 here. You can see that the sum is equal to 1 and carry out is equal to 0. Sum is equal to 1 and carry out is equal to 0. Similarly here. Now we go to the next. When B and C in is both are the 0 1 1, we can verify this. Now the sum is equal to 0 and carry out is equal to 1. Similarly here in both circuits. Now we go to this. When A is equal to 1 and both other are 0 0. A is equal to 1 and both other are 0 0 here. Then 1 0, sum is equal to 1 and carry out is equal to 0. Sum is equal to 1, carry out is equal to 0. Similarly in this circuit. Now next, A and carry in is equal to 1 1. Sum is equal to 0 and carry out is equal to 1. Similarly in this, now A, B are the both are the 1 1 and carry out is equal to 0. carry out is equal to 0. It shows the sum is equal to 0 and carry out is equal to 1. Sum is equal to 0 and carry out is equal to 1. When all the a, b and carry in is equal to 1 1, then it shows the sum is also 1 and carry out is equal to also 1. So hence the full adder circuit is also verified by the truth table. That's all for this lab.